Hello, welcome to another of the Richardson lectures on river landscapes in the UK. Today we're going to be looking at factors increasing flood risk and hydrographs. We need to be able to identify and explain the physical and human factors that increase flood risk, and also to describe the characteristics of hydrographs and explain how different catchment characteristics affect the shape of the hydrograph. So flooding. Well, flooding is a natural phenomenon. It occurs when the river channel can no longer hold the water it's carrying and the water leaves the banks, leaves the channel and floods the surrounding land. And even though it is a natural phenomenon, the risk of flooding can be increased by both physical and human factors, and the results of flooding are a range of social, economic and environmental effects. Now, the volume of water flowing through a river is called its discharge, and that's measured in cubic meters per second. And whilst an individual flood event is caused by a particular rainfall event, there is actually a range of factors that can lead to a rapid rise in river discharge and therefore increase the flood risk. So we're going to take a look at some physical and human factors. And the first one is heavy precipitation. Precipitation, a fancy word for rainfall in this case. So a heavy rainfall event will directly put water into the river channel, increasing the volume, therefore increasing the chance of flooding. But it also does something else, because when the rain is falling on the land, because that rainfall is coming down so fast, it cannot infiltrate or soak into the soil layer, and instead it flows over the land. A surface runoff that reaches the river and then increases the river discharge. So here we've got some of the water infiltrating into the soil, but a lot of it will not, because it's so heavy, and so the water flows over the land, surface runoff gets into the river, increases the discharge, increases the risk of flooding. There's a repeated theme as we look through these factors. We've then got prolonged rainfalls. That's when rainfalls are taking place over long periods of time. And we've got infiltration taking place here, water's infiltrating into the soil, and that keeps on happening until the soil layer becomes saturated. And when that soil layer fills up with water and can no longer hold any more water, then we will see surface runoff over the land into the rivers, and again increasing that river discharge. Geology is also very important, and that's going to vary depending on the river basin. If the river catchment's got permeable rocks, such as sandstone, these allow water to pass through. They've got pore spaces in sandstone between the sand grains that allows water to move into the rock, and water can be stored there. So if more water is going to be into the rock, less is going to reach the river. So water can move into the rock, less of it is therefore reaching the river channel. However, with impermeable rocks, such as something like a slate or a granite or a shale, they're impermeable. They do not allow water to pass through, and instead when the water hits these surfaces, it runs straight over the land and into the river, rapidly increasing the river's discharge. So the geology is really important in determining how it's going to impact discharge of the river. Relief is also really important, so that's referring to the shape of the land, how steep the slopes are. And obviously if you've got steeper slopes, we're going to have a faster transfer of water across the surface and into the river. So we've got a steep side and valley here, a V-shaped valley as you would expect in the upper course of a river. And because of those steep slopes, water is going to run quickly over the land here into our valley bottom and increasing the volume of water in that channel very quickly. We've then got some human factors that increase flood risk, things that us as humans have done, change the landscape to increase the flood risk. And the first one is urbanisation. So in this case we're talking about the expansion of the built environment where humans live. Now part of this is that we build on floodplains. Floodplains are natural, they are areas of land which naturally flood. So by us building on them we're putting our property and lives at risk. But also urban surfaces are also impermeable. So things like concrete and tarmac are impermeable, and that leads to increased surface runoff. So in this, we've got an urban area here with lots of tarmac and concrete. That rainfall is not able to soak into the ground below, and instead we'll have lots of surface runoff. It runs straight off the land into our river channel and increases the discharge. Next up, deforestation. Well, first of all, we'll talk about trees. Trees are brilliant. They're a natural way of reducing flood risk because they intercept or catch the rainfall. So it reduces the amount of rainfall actually reaching the river channel. So these are actually a good way of naturally reducing flooding. However, a human cause here, by us deforesting the landscape, cutting down the trees, we actually reduce that interception, expose more land as bare land, and therefore we increase the amount of surface runoff, and again increase that discharge in the river channel. And lastly, agriculture or farming. This can also increase flood risk in a couple of ways. If the area has been used for arable farming or crop farming, we often see scenes like this where we've got lots of exposed land. There's no vegetation here soaking up, intercepting that rainfall, and therefore we see more of it draining off land and reaching rivers. And actually, if the land is not tended to for a period of time, we get this kind of hard crusty layer on the top of the soil, which acts as a sort of impermeable barrier, increasing water flow off the land and into our rivers. But also livestock farming, pastoral farming, also increases the risk because farm animals, particularly large animals like cattle, as they're walking over the land as they graze, they're compacting the soil, and the upper layer of the soil becomes very compact, and again it helps to create this impermeable barrier which allows water to flow over the land as surface runoff, increasing the river discharge and therefore the risk of flooding. So now we're going to talk about hydrographs. Now these are graphs we use to show how a river's discharge, the volume of water in the channel, how it responds to a particular rainfall event. So they're used in storm events to track how a river responds to a particular rainfall event. So we've got two sets of data here on our vertical axis. We've got discharge and rainfall, and then along the bottom we've got time. Now, what you often see on a hydrograph is a line like this. This marks base flow. This is the normal flow conditions of our river. But what we're interested in is how our river responds to a particular rainfall event. So here we've got some rainfall plotted on as bars. Obviously that's going to add water to our channel and increase its discharge. And so what you'll then see, we have a curve here. This is our discharge curve, and we can see where the water level's rising. We call it our rising limb. And when the water level falls, we've got our falling limb. And the shape of these limbs is important when you're describing hydrographs. And finally, a key feature of hydrographs is this. This is the lag time. The point between peak rainfall and peak discharge. It's the time between them. Obviously, the shorter the lag time, the quicker it's been as water's made its way from the land into our rivers. So we'll take a look at that in two different examples. So here we've got a rainfall event. We're going to have the same rainfall event for two different catchment areas. So here's our first one. It's got impermeable bedrock, so the water can't soak through. It's been deforested, the trees have been cut down, and we've got lots of urban impermeable surfaces nearby. So this river is going to have steep rising limb and a steep falling limb. The water's running off the land very quickly, all these characteristics leading to that, causing the water level to reach the river very quickly and also therefore to pass through the system very quickly. And we've also got a very short lag time, so it didn't take long for that water to reach its maximum in the river. Whereas our second hydrograph, and I'll leave the first one on as in the background there, here we've got a permeable bedrock, we've got lots of forest, and we've got these gently sloping landscapes, all characteristics to slow down the flow of water. And so our discharge curve here looks like this, with much more gentle rising and falling limbs and a longer lag time. Now there's two really important things here. This is, if you were living in one of these catchments, you would want to live in this second one. Not only has it taken longer to reach peak discharge, so giving people more time to respond to this flood event, but also you'll notice because it's taken longer, the maximum peak discharge is also less, and so the actual impacts of the flooding will also be less. And this is why, as a response to flooding, using more natural methods of flood management, so reforesting the upland areas, is becoming a very popular response to try to tackle flood risk. If you forest up lots of areas, you're increasing the the lag time, and overall lowering that peak discharge, reducing damage downstream. So we'll just finish by taking a look at a couple of exam questions. So first of all, here we've got figure 14. It's a photograph showing urban flooding. And we can see the question says, with the help of figure 14, so we must refer to the figure, explain how physical and human factors can increase the risk of river flooding. So apart from the figure bit, this is really just a knowledge question. You need to explain the ways that flood risk can be increased, both physical and human factors. So we need to do that. We need to have at least one or two physical factors explained, so things like your steep slopes or your geology, talking about impermeable rock. And then a clear explanation of one or two human factors. If you're going to do one physical, you'd want to do two human, or vice versa. But of course, because this is a figure question as well, we must refer to the figure. And we can see that this is an urban environment, so we can talk about how urbanisation increases flood risk, a human cause of increased flood risk. And we can say that in the image we can see lots of concrete and tarmac, which are impermeable, which increase the flood risk. So you must refer to the figure if you're going to access the top marks, even if your knowledge explanation in the first part of this answer is very good. And then lastly, one more question. We've got figure 14 here. This is showing some flood hydrographs for two different streams after the same storm. So we've got two hydrographs. We've got Ostwick Beck and Clapham Beck, and as you can see, the rainfall is exactly the same, but the discharge curve is very different. And then the question states, we've got a statement first of all, it says differences in the shape of the flood hydrographs are caused by both human and physical factors. Do you agree? Use figure 14 in your own understanding to explain your answer. Now there's a lot of overlap actually with the previous question. There's some knowledge here explaining physical and human factors, but we also need to talk about these hydrographs and make some links. So first of all, we need to have a clear comparison of the two hydrographs. We need to talk about the rising and falling limb, the shapes of those. So we can see that in Ostwick Beck we've got steep rising and falling limbs, whereas Clapham Beck much more gentle. We'll talk about peak discharge and how that's much higher in Ostwick Beck than it is in Clapham Beck. And we can also talk about the lag time. So here the lag time very short, here much larger. You also need to explain then the physical and human factors which impact discharge and make links to the figure. So we can talk about steep slopes, for example, and we could suggest, we don't know, we're suggesting, it's a sensible suggestion, that Ostwick Beck has steeper slopes because that's what's allowed the discharge to increase. We could also talk about human factors such as deforestation, and we would suggest that Ostwick Beck has experienced greater deforestation, there's less vegetation here, because waters reach the channel quicker, hence that higher discharge curve. And you must also refer to your opinion. It does ask you, do you agree? So you should really start your answer with a simple yes or no, do you agree or not? And it is a case of yes, you must agree with this, because we know that both physical and human factors do impact the shape of hydrographs. Okay, that's it for this video. Next time we'll be talking about flood management strategies, both hard and soft engineering.